Here is a problem based on electric field. So this problem is to find out the total electric field due to two charges. I'll write the problem. Two charges plus Q and minus Q. Q, two charges Q and minus Q are kept at x minus x2 comma 0 and plus x1 comma 0 respectively in the xy plane. In the xy plane. Find the magnitude and direction of Find the magnitude and direction of the net electric field at the origin. Zero comma 0 at the origin 0 comma 0. So we have two charges Q and minus Q kept at minus 2 comma 0 and x1 comma 0 respectively in the xy plane. Find the magnitude and direction of the net electric field at the origin. The origin point is 0 0. The coordinates x and y coordinates are 0 0. How to find out the solution for this? I'll write a note here. Let me write a note here. To find the electric field intensity at a point due to two charges, to find the electric field intensity at a point due to two charges. First, find the individual electric fields. First, find the individual electric field. First, find the individual electric field due to both charges. And then find the resultant field using the vector addition. Resultant field due to vector addition. So here given two charges plus Q and minus Q. Let me say this is the origin O, 0 0. So origin O, and one charge is at minus x2y. Or we will draw the xy plane. We can draw the xy plane also. This is the origin 0 0. So XY plane, origin 0, 0, and one charge is at minus x2, 0. So this point is minus x2, 0, and this point is x1, 0. XY plane. Now you have to find out the total electric field at origin O. So we will first, I have given in the note, the electric field intensity can be found by finding the electric field intensity due to each charges individually, and then you do the vector addition. So let E1 is the electric field intensity at O due to plus Q charge. Electric field intensity at O due to plus Q charge. So plus Q charge is here, and this is minus Q, is E1 equal to 1 by 4 pi epsilon naught into Q divided by x2 square. Since it is vector, so it is plus Q charge. We know that for positive charge it is away from the charge. If I mark 2 points A and B, or I can write here away from plus Q. So the direction of E1 we can mark in the figure. This is E1. Similarly, electric field intensity at O due to minus Q charge as E2 equal to 1 by 4 pi epsilon naught into Q divided by x1 square. It is a minus charge. So for a minus charge, the electric field intensity is towards the charge. So I can write here towards minus Q. The direction is towards minus Q. So at point O, E2 can be marked as towards minus Q. This is minus E2. Both the fields are acting along the same direction. E1 and E2 act along the same direction. So net electric field is the addition of these two. E1 and E2 act along the same direction. Therefore, net electric field intensity at O. Net electric field intensity at O as E net equal to E1 plus E2. Add these two electric fields, you will get the net field. One by 4 pi epsilon naught into q by x2 square plus 1 by 4 pi epsilon naught into q by x1 square. Take out the common terms outside. Q by 4 pi epsilon naught into 1 by x2 square plus 1 by x1 square. This is the answer. The net electric field at O, at the origin, is given by this equation. So the electric field acts towards minus q, or you can write acting away from plus q. The net field will be, if you want to mark this on your diagram also, you can mark. We have minus q here. This is plus q. This is origin O. E1. E2, and the net field is acting along the same direction. The net is also acting along the direction of E1 and E2. E1, the direction is important here. E1 is away from plus q and E2 goes towards minus q. Because E1 and E2 are in the same direction, the net field E can be just obtained by the vector addition.